No Atom, Grade 5, Unit 2, Earth Materials, Student Reader. Section 1, Earth's Minerals. The Hope Diamond. A museum in Washington, D.C. holds the world's largest deep blue diamond. This 45-carat blue diamond is the size of a walnut. It is called the Hope Diamond. Caption: The Hope Diamond is on display at the Smithsonian Museum in Washington, D.C. The Hope Diamond has long fascinated humans. More than 100 million people have visited the museum to see the diamond. It was first discovered in India in the 1600s, but its history goes back far beyond that. Scientists believe it is at least 1 billion years old and was formed so deep inside Earth that humans cannot travel there. How diamonds form. All diamonds are formed deep within Earth, at least 161 kilometers, 100 miles, below the surface. They can only form under tremendous heat and pressure. This heat and pressure are a result of Earth's structure. The center of Earth is a solid ball of metal, iron, and nickel. It is called the inner core. The core is 7,000 degrees Celsius, hotter than the surface of the sun. The outer core wraps around the inner core and is made of liquid iron and nickel. The mantle is located around the outer core. The mantle is Earth's thickest layer. Imagine an apple. The core of the apple is like Earth's core, and the fleshy part that you eat is like the mantle. Earth's mantle is an ocean of semi-solid rock called magma. It is here where diamonds are formed. Earth's skin is its crust. The solid crust is the coolest layer of the planet that forms the continents and holds the oceans. Diamonds are minerals. Diamonds are made mostly of a single element, carbon. The heat and pressure of Earth's interior cause the carbon atoms to join together in a way that results in the unique physical properties of diamonds. Diamonds are minerals. Scientists have found more than 3,000 minerals, made up of different combinations of elements. All minerals are naturally occurring, which means they are not made by humans. They would exist on Earth without people. Minerals are also inorganic because they are not the product of something that is living or was once alive. Leaves and shells are organic because they come from something that was once alive. They also have a definite chemical composition. This means that every mineral is made up of the same kind and number of atoms. For example, diamond can always be described by the chemical formula of C since it is made up of carbon atoms. Lastly, minerals have an orderly crystal structure. This means their atoms are neatly organized to form a repeating pattern. Caption: A diamond's crystal structure of carbon atoms. Identifying minerals. One of the reasons that people are drawn to the Hope Diamond is its color. Blue diamonds are very rare. They are blue because they have traces of the element boron combined with the carbon atoms. Diamonds come in many different colors, including red, yellow, green, purple, and brown. Color is one property that scientists use to identify minerals. In addition to color, there are many other property tests that science can do to identify a mineral. For example, scientists were fascinated to discover that the Hope Diamond gives off a fiery red glow after it has been exposed to ultraviolet UV light. This is called phosphorescence. Scientists have learned that all natural blue diamonds glow red for about 5 minutes after being exposed to UV light. However, blue diamonds created by humans give off different colors. Because of this, phosphorescence helps scientists determine whether a blue diamond is real or fake. Other diamonds do not phosphorescence. Instead, they fluoresce, which means they give off light only as long as UV light is shined on them. One of diamond's most well-known properties is its hardness. Hardness is a measure of a mineral's resistance to scratches. Mineralogists use a 1 to 10 hardness scale called the Mohs scale. Talc is a 1, which means it is very soft. Diamond, in contrast, is a 10, making it the hardest naturally occurring mineral. It is so hard that only another diamond can scratch it. Its hardness is caused by the way that the carbon atoms join together. The hardness of diamonds makes them useful for different applications. For example, they are used in cutting tools for military materials, such as airplane parts and armor. Caption: this is a blade that has diamonds in the metal. Most diamonds are also excellent electrical insulators. This means that they do not conduct electricity. Conductivity is tested by placing the mineral in a circuit and seeing if it conducts electricity. However, blue diamonds such as the Hope diamond are semiconductors. Depending on what other molecules are around, semiconductors can sometimes conduct electricity. Blue diamonds can sometimes conduct electricity because boron is a semiconductor. Diamonds are also excellent thermal conductors. This means they conduct heat. This explains why diamonds feel cold to the touch. Scientists rarely rely on just one property test when they are identifying a mineral. Many minerals share some of the same physical properties, including color and hardness. However, when many of a mineral's properties are examined, it often results in a unique set of properties that can be used to correctly identify the mineral. For example, in addition to hardness and conductivity, scientists look at a mineral's luster. Luster is the way light reflects off of a surface of a mineral and how bright, dull, or greasy the mineral appears. Caption: this diamond has a high luster because its surface reflects light. Luster falls into two categories: metallic and non-metallic. Cut diamonds also often have a metallic luster. This gives them a brilliant, freshly polished look. In contrast, uncut diamonds can have a greasy or dull luster. Pure diamonds are also the most transparent known material. Transparent substances allow light to pass through. Pure diamonds are rare, however. Some non-pure diamonds are translucent, which means they allow some light through and absorb some light. Opaque diamonds absorb all light.